It's nice to be with you again. We are now in your lecture for Analytical Chemistry. And this is your second part for your introduction in Analytical Chemistry. So for this meeting, we are going to discuss some salient points about analysis. So as defined, analytical chemistry provides the methods and tools needed for insights into our material world, for answering four basic questions about a material sample: what, where, when, how much, what arrangement, structure, or form. These are your concerns in analytical chemistry. Analytical chemistry is sometimes called as the science for chemical measurements, and it is the chemistry discipline concerned with chemical composition of materials or substances in it. So if we're going to look at analytical chemistry provides the tools and the eyes scientists and engineers require. So how this could happen? First, the analytical chemistry characterizes materials, whether it is soft or brittle, and then observe experiment to know more characteristics. Observing the experiment is analysis, and in analytical chemistry, this is all that you are going to do. This is your language. To observe, to observe, to analyze, analyze, and observe. So there are different types of analytical chemistry or concerns of analytical chemistry: the qualitative side of a matter and the quantitative side of matter. If we're going to look at the qualitative side of matter, we are referring to the what. What is present in a certain substance? What is present in the test tube? And in quantitative chemistry, it is asking how many, how much is that matter present in the test tube. So if you are holding, for example, a certain food, let us take our vinegar, the sukabasi. If we're going to look into some qualitative nature of our sukabasi, we are asking what is the taste? Of course, it is sour. So how are you going to measure the sourness? How are you going to prove that it is sour? So you get your pH paper or you get your pH meter. If the red litmus paper changes into red, what is this? If the blue litmus paper changes to red, what is this? So you know that the quality is sour, but you cannot describe how sour is this. You get an instrument to do it, one of which is the litmus paper. If the blue litmus paper changes to red, you are sure that that is an acid. So since you know that it is an acid, you are sure also to say that it is sour in an ordinary analysis. But the question is, what then if it is an acid? What is its acidity? This is now where your quantitative chemistry comes in. So you could measure this, the pH, even by using pH meter, because it will tell the extent of pH. Or you could just simply get your pH paper. But if you want an instrument or an apparatus to use it, you could use the pH paper. And another way is what we usually do in quantitative analysis is to look for the H. Because you know that pH refers to the pre-hydrogen atom. So we want to determine how much is that. And through the process of titration or using your burette and a standard solution, whether just acid and base, you make some reaction or what we call magic with your phenolphthalein, then you could determine how much is the H plus. So analytical chemistry deals both with what is present in such, what is its nature, and then after identifying what is this, the next question is how much. Progress in measurement sciences involves both targeted and basic research. In targeted research, you identify the specific problems and then you apply some novel existing principles in order to meet your specific problem. And then in basic research, this includes innovative concepts. So you make use of new principles. And both of these make use of characterization and analysis. And that is where your analytical chemistry comes in. In front of you, these things are actually flame. The color of the fire or the flame here is green and also green. But the extent of the color or the intensity of the color differs. You can call this as yellow-green. You can call this also as just simply green. There are different shades of other colors here. You have here the red and you have here orange. If you are not careful in your analysis, you might consider this as orange. And of course, this is yellow and this is violet. If the background or the light of the background is too intense, the yellow color can also become white. So, analysis in chemistry makes or requires sensitive analysis, not just simply, oh, it says like this. The word seems here or looks like is not welcome. It should be of great accuracy or precision. Areas of chemical analysis and question the answer for better quantification and identification. Detection. Does the sample contain substance X? Identification. What is the identity of the substance in the sample? Separation. How can this species of interest be separated from the sample matrix? Quantification. How much of the substance X is in the sample? So, if in the laboratory, if only you are working in the laboratory, what is usually given to analytical chem students is a test tube containing an unknown, and that is the X. So, if also you are in a commercial laboratory, let us say, for example, you are given a milk tea, but that milk tea had caused the death of person XYZ. So, what is your objective here? To determine what had poisoned person XYZ. So what is that poison is your unknown, and you could mark that as your substance X. So is the milk tea or the sample really contain substance X? Does the milk tea really contain poison? Identification is next. How are you going to identify the sample? So you are guided with many kinds of tests in your lower chemistry, especially in biochemistry. There are so many tests that you have done. Tests for different organic compounds, from hydrocarbon to more complex functional group. You were able to do all these things. Just as the same in your inorganic chemistry, you have several exercises that required you to determine a certain substance that is present in the periodic table and classified as inorganic. You have even experiment on hydrogen for you to know what is the character of hydrogen. You have an experiment also on halogens, FClBrI, to remind you, no? And you have a specific test for this. So if you could still remember, you have done an experiment on test for hydrogen, test for halogen. Specifically, you have done also things like test for the presence of fluorine, test for chlorine, test for iodine, and also you have tried to compare even the rate of reaction. So you are trying to identify what is that substance. So if, for example, in the milk tea, you have applied a test on the presence of um, halogen because it was believed that someone had placed Clorox. And you know that Clorox contains chlorine or any other bleaching substance or any other chemical that is organic in nature. But more or less, since there is a claim that Clorox might be added, so you go for the test of halogen. But you should know how to separate the halogen in order to test for the presence of halogen. So here comes now the test for separation. And then the last one is how much. Because there are some instances that a poison might be present there, but the quantity is not enough to kill the victim. Or maybe you can say that alcohol is present in his body, but when you have done a blood analysis, yes, alcohol is present, but the quantity is not enough to make that person intoxicated and incapable of driving a car. Can you get it? So that is what you are going to do supposedly in the laboratory. So if you were that tired in your organic chemistry, if you were tired in inorganic chemistry, so with biochem, but unluckily you were not able to have laboratory in biochem because of the COVID quarantine period. You will do similar things. You will do a lot of testing here in the laboratory. Okay, here are the basic steps that are supposed to be done in the laboratory. An analysis involves several steps in operation, but you are guided on the following: the particular problem. If your unknown, for example, is looking for a silver, then you go for the test for the group of silver. So you go to your periodic table, look for where silver is, what is its group number, and then you research on the test for the group number of silver. And then next, were you trained to do analysis? You were trained to do analysis in organic chemistry. The same true as in your inorganic chemistry. The next question is, do we have sufficient apparatus, equipments, and chemical needed? Yes, we have. The analyst should be careful to involve step-by-step analysis because every step might mean a result that is crucial in confirming whether that substance X is present or not, whether that substance X is more than 10 parts per million of the solution. Okay, it's lengthy, it's too long. You might be thinking, but you will be doing this. So, first is define the problem, select a method, obtain a representative sample, prepare the sample for analysis. This is the most enjoyable part of analytical chemistry. Prepare the sample for analysis. Then perform any necessary chemical separation. This is also an exciting uh, part of analytical chemistry. Perform the measurement and then calculate the result and report. Where will analytical chemistry divide itself in this analysis? You could not just simply go to quantitative analysis without going to qualitative analysis. So your qualitative analysis goes to preparing the sample for analysis and also likewise performing any necessary chemical separation. But if we say already measurements, calculate, that is more of the work in quantitative analysis. In some courses, analytical chemistry comes in 10 units. 5-unit qualitative chemistry and 5-unit quantitative chemistry. But in your case and in some other courses, analytical chemistry is just simply 5 units. Let us try to look into each step. Let us define the problem. What does defining the problem ask you? What are the factors that you should consider? First is, what is the problem? What needs to be found? Are we looking for mercury? Are we just simply been asked to test for the presence or absence? If that is the case, we are only referring to qualitative. But if the problem says how much mercury is present, how much, that is already quantifying. So that is quantitative analysis. Now next is, what will the information be used for? Who will use it? Maybe you are testing the mercury because the test here is to test for the presence of mercury, to test for the presence of poison, and the subject here is mercury. Who will use it? Maybe the fishermen. Maybe the fishermen had observed a fish kill in the river. So they might be accusing a certain big factory releasing mercury containing or arsenic containing substances. The next question is, when will it be needed? Uh, Chemical analysis needs time frame, especially if the chemicals demand for freshly prepared. Freshly prepared is starch. I'm sure you have encountered that in organic chemistry. The analyst should consult with the client to plan a useful and efficient analysis, including how to obtain a useful sample. So if you are doing some investigation, this is a very important thing to do. So sampling of the sample is needed. And there are some techniques in sampling. Next, select a method. Now, what are your concerns? The sample type. Is it frozen? Does it require a certain temperature? What is the size of the sample? Do we need gallons of this? Do we need 10 liter or just simply 10 ml? What is the sample preparation needed? What concentration or range? Is it so sensitive? Will it make use of nanometer? Will it make use of just simply micrometer? Or will it make use of parts per million in order to define the concentration? Selectivity needed. What are your interferences? Accuracy, precision needed. Will the accuracy mean 0.00 error level of significance? What are the tools and instruments available? Of course, the expertise depends on your patience or perseverance in doing the experiment. How much? What? How long? Does it need to be automated? So does it require high-tech facilities? Are the methods available in the chemical literature? Most of these are available, and most of which you could already download in your internet. Are standard methods available? Usually, there are. Next, obtain a representative sample. So, what is the sample type, homogeneity, and size? Sample type. Do I need a concentrated type? Homogeneity. If I'm going to gather a sample in the river, will I get a sample from every corner in the center and also likewise in the center? Or will it just be enough that I will get sample water or sample liquid in any part of the river? How many liters will I need? How about the sampling statistics error? Well, this is another computation. That is another concern. Then next, obtain a representative. Prepare the sample for analysis. Again, the form is needed, or will you already need to, is there already a need to dilute? If it is a solid sample, does it require for immediate uh, action like dissolving this or adding a certain solvent? And then in the lab, do we need to ash this to remove extra moisture? Do we need to digest this in order to separate the nitrogen or to separate the fat present? Chemical separation and masking the interferences needed. Do we need to concentrate the analyte? And is there a need to change the analyte for detection? Or Is there a need to adjust solution condition? All these things are your concern for the preparation of sample for analysis. Usually, there is a package procedure, so it will tell you or it will guide you to decide what you are going to do in this uh, part of your analysis, preparing the sample. Another is perform any necessary chemical separation. What are the uh, things? Will it just be simply enough for you to make use of some chemicals to separate a certain substance, or do you need a more complex one? Do you need some sort of electrophoresis, or will you need to confirm your substance X by using chromatography, or will it just be enough that first you have distillation or precipitation and then just simply extracting the sample by adding solvents or testing this right away with another chemical? Then next is perform the measurements. You could perform the measurements by calibration, validation, and replication. This is all done by machine. And then you calculate the result, and this includes a lot of computation. So once you have determined the substance, you go for testing for quantification, and then you do necessary computation like statistical analysis. If needed, you could test for the level of accuracy of your sample. There are several applications that you could meet in your internet to, to do further investigation to make your computation precise. Okay, there are different methods that provides different result, and this depends upon the range of precision, the sensitivity, selectivity, and speed capabilities. All these things you will encounter and you will experience in the laboratory. These are different standards. These are things that are given. So if you are testing for tithymetry, you could have just simply 10 to the 1, the approximate range, or 10 to negative 4 mole per ml. And then for the selectivity, this test is from poor to moderate, especially if you don't have enough skill. The speed is moderate, the cost is low, and the principal uses is for inorganic determination and organic uh, determination. Tithymetry is the most common procedure used by students in analytical chemistry. Although uh, you will be exposed to the use of the spectrophotometer in the latter part. Paper chrome, this you have done this already in organic chemistry. So when you will have this, all that we could introduce to you is the paper chromatography. Okay, sample size dictates what measurement techniques can be used. So again, these are the analytical methods according to the size of sample. So if the method requires for meso, semi-micro, micro, ultra-micro, these are the sample weight. or if they come in by liquid, these are the sample per volume. So the sample per volume is in microliter, and then for sample weight, the milligram. I think you know what is microliter, that is referred in the volume. Sometimes the simple lambda is used to replace m. So this is also microliter or your milliliter. But in some analytical chemistry, they make use of the microliter. Chemical analysis affects many fields, from physical to organic. The theory guides but experiments decide. This is what you always remember. You need your theories to guide you in your experiment. There are some instances that the procedure will no longer explain why you are doing that. The procedure will just simply tell you what to do, but the theories that you have learned will tell you and explain you why is that happening? What is happening? How did that happen? Why did it happen? Those are the things that your lecture will tell you, or lectures in your other chemistry. The background of your study in chemistry tells you. The theories that explains the experiment that you are doing now. Another is biotechnology. Chemical analysis distinguish distinct structure from one another, especially your isomers and your bio biosenors. Then material science. It is example for this is uh, in relation to energy conductors, which is of a high demand in terms of study today because of the many gadgets that we are using now. And then in the manufacturing, quality control of not only of packaged food but also uh, pharma drugs or your medicines, and also your um, specific parts of the gadgets that we are using now. So sometimes you can hear the word based on nanotechnology. So meaning to say, there is an accuracy in the measurement up to nano level. And then forensics, of course, analytical chemistry does a lot of investigation. So this is all for this meeting. This man is demanding for text break, and of course, I am sure you are smiling like smiley. So our next meeting will be already in your laboratory activities. Please go back to your Google Classroom for your activities.